So what we're discussing here are three different things. First, there's the distance formula. As you see, it's d is equal to the square root of the quantity of x sub 2 minus x sub 1 raised to the second power plus the quantity of y sub 2 minus y sub 1 raised to the second power. The x sub 2's and x sub 1's, y sub 2 and y sub 1, they're found by the problem giving you 2 points or 2 ordered pairs. Same thing for the midpoint formula. The problem should give you 2 ordered pairs, right? 2 points, and then you can substitute into the formula, which is midpoint is equal to x sub 1 plus x sub 2 divided by 2 and y sub 1 plus y sub 2 divided by 2. There's a comma in between because those create an ordered pair, another point. So the midpoint is a point that is directly in the middle of these 2 points that are given. You can see it's just basically taking the average of the x's and the average of the y's. And then lastly, this last equation is the equation of a circle in standard form. It's x minus h to the second power plus y minus k to the second power equals r to the second power. So our first example is to find the distance between these 2 points. The first point is 2 times the square root of 7 and the square root of 3. So the x value is 2 times the square root of 7 and the y value is the square root of 3. And the other ordered pair has the negative square root of 7 and 2 times the square root of 3. So my first step would be to rewrite that distance formula that we know. So the distance formula we stated earlier was d for distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Right. The next thing I may want to do is go ahead and identify my x and my y in each group of ordered pairs. I have x and y. Well, reading from left to right, this is the first set of ordered pairs that I see, so I'll label those the sub 1's. This is the second set of ordered pairs, so I'll label those the sub 2's. And now it's just much easier for me to go ahead and substitute in. So I'm just going to make sure I put the minus sign from the formula in. A lot of times people forget that minus sign from the formula, so I don't want to forget that, so I'll put that in right away. And then that way, if the values x and y have other signs, I'll just write them in while I'm doing it. So x sub 2 is the negative square root of 7, and we already have a minus sign, so I'll fix that. And then x sub 1 is 2 square root of 7. Alright, the next thing we substitute in is the y sub 2. Y sub 2 is 2 square root of 3 minus y sub 1. Y sub 1 is the square root of 3. So after substituting those two in, we'll go ahead and do the math. We do what's in the parentheses first. A negative square root of 7 minus 2 square root of 7. So in front of every radical, we know that there's an invisible 1 there. So that's an invisible negative 1 square root of 7 minus 2 square root of 7. Well, the signs are the same, so we add them. So negative 1 and negative 2 make a negative 3 square root of 7. And that's all to the second power. So I do what's in the parentheses of that second parentheses there. So we have 2 square root of 3 minus, and again there's an invisible 1 in front of the square root of 3. So 2 minus 1 is just going to be 1 square root of 3, or we can just write square root of 3, right? Because again we know there's an invisible 1 there. And then that's raised to the second power. So as we move down some, we go to the next step. The next step is to square each of these inside of the parentheses. So we're going to square negative 3 times the square root of 7. So for us, negative 3 to the second power is going to make 9. 9 times the square root of 7 to the second power. Right? When we square a square root, they're inverses of each other, so they'll just both go away, and we'll be left with the radicand, which is 7. right? And then we'll say plus the square root of 3 raised to the second power. And again, when we square a square root, we're just left with the radicand. Alright, now in the next step we have 9 times 7 is 63 plus the 3. The distance equals the square root of 66. Square root of 66. It looks like I can't break down the square root of 66 any further. If you think about it, you look at all of your perfect square roots and say, okay, can any of those go into 66? For instance, can the square root of 4 go into 66, or the square root of 9, or the square root of 16, or the square root of 25, or the square root of 36? None of those go evenly into 66. Therefore, I can't break this down, and this is my final answer. The distance is the square root of 66. Now in this example, we look to find the midpoint of the line segment with the order pair of -3/4, 5/8, and the order pair of -1/4, -3/8 as the endpoints. So we're going to find the midpoint between those two endpoints. So the first thing I'll do is write down the the midpoint formula. So the midpoint formula, as stated above earlier, was x sub 1 plus x sub 2 over 2, right? It's just like taking the average of the x's, comma, y sub 1 plus y sub 2 divided by 2. Again, now we're taking the average of the y's. So the first thing I'm going to do is just go up here and just label our x's and y's. X and y, x and y. Well, reading from left to right, I'll label these the sub 1s because they're the first. This is the first order pair that I see. I'll label these the sub 2s because this is the second order pair that I see. And now I'll just go ahead and substitute in to my formula. So my formula has x sub 1, which is -3/4, plus x sub 2, which is -1/4, all divided by 2. And then we have y sub 1. Y sub 1 is 5/8 plus y sub 2. So that's plus a -3/8 all over 2. Alright, so what I need to do here is first add the fractions in the numerator. So a -3/4 and a -1/4, that makes a -4/4. That's still over 2. A 5/8 minus 3/8 makes 2/8, and then that's over 2. Alright, so now we look at it a little further. So -4/4 is -1 over 2. And then we have 2/8 over 2. Well, 2 over 8 is like saying 1 over 4, and that's over 2. Alright, so here's what we have to look at just a little bit further. So we have the -1/2 that I'll bring down, that 1/4 over 2. I'll take my work on the side here. So 1/4 divided by 2, right? Over 2 means divided by 2. And when we write 2, we can write it as a fraction as 2 over 1. Well, we know from our times doing division of fractions, we make this 1/4 times 1/2, right? When it's division, we change it to multiplication, and we go ahead and flip that second fraction. And now we can just multiply straight across. 1 times 1 is 1. 4 times 2 is 8. So therefore, that 1/4 divided by 2 is actually 1/8. So my midpoint is -1/2, 1/8. Third problem is asking us to write the standard form of the circle with the center of -8, 5 and a radius of the square root of 11. So we're looking to write this in standard form. So standard form for a circle is x minus h raised to the second power plus y minus k raised to the second power is equal to r to the second power. Alright, so it's important to understand here that the h and the k, those two values represent the values of the ordered pair for the center of our circle. So h and k give the center, and we must know to use the opposite values when we're plugging in for h and k. Alright, and r is the radius. Here it's r squared, but r by itself is just the radius. Alright, so here's what we're going to do. We're given negative 8 comma 5 as the center. It's given to us, and the radius is the square root of 11. So this value, negative 8, is our h and 5 is our k, but however, remember I said that we need to be using the opposite, right? Because if we were to plug in this negative 8, x minus a negative 8 gets us x plus 8, right? Because our value of h is a negative 8, but if we plugged it in, a negative and a negative makes that a positive 8 squared. So this is added to y, and then our k value is a positive 5, and the negative times that positive sign that's in front of that 5 makes that 5 a negative, and then that's raised to the second power. And now lastly, the radius is the square root of 11, and I'll write it way on the left here. No, maybe I'll write it on the right. So the radius is the square root of 11. So what we have is r squared, right? So we have the square root of 11 raised to the second power here. So we know that when we square a square root, we're just left with the radicand. So therefore, we'll say 11. So our standard form for the equation of a circle with a center of negative 8 comma 5 and the radius of the square root of 11 is x plus 8, that quantity squared, plus the quantity of y minus 5 squared equals 11. Our fourth example says to write the equation of the circle in standard form and give the center and the radius. So they give us x squared plus y squared minus 3x plus 5y minus 1 equals 0. So first we need to think back to the equation of the circle in standard form. When given to us, it was the quantity of x minus h to the second power plus y minus k. That quantity raised to the second power equals r to the second power, right? And remember, the h and k were the center of the circle, and r represents radius. So here it's surely not in that form. The first thing I'm going to do is move this 1 over to the right. So I'll do that by adding 1 to both sides, right? Because at least it'll look somewhat similar to that standard form for a circle with a constant on the right. So then I have x squared plus y squared minus 3x plus 5y equals 1. So looking at this, there's something special I can do. If I have the x squared and the negative 3x together, and the y squared and the 5y together, I can think back to one of my old techniques. Remember, we did completing the square. So completing the square, partially doing that method on this problem. So let's give that a try. So I'll take that negative 3. The negative 3 is like my b value, and we would use b over 2 squared, if you recall from the completing the square method. So I'm going to do that. So I'm going to take negative 3 over 2 and square it. Well, I want to do the same thing to this 5. Take the 5 over 2 and then square it. Alright, so what happens when I square them? So I get 9 fourths, and over here I'll get 25 fourths. 9 fourths and 25 fourths. As you recall from completing the square method, we would take that 9 fourths, add it to both sides, and same thing with the 25 fourths. So x squared minus 3x plus 9 fourths, right, plus, we'll say y squared plus 5y plus 25 fourths. And that's equal to this 1 that's still over there. But in completing the square method, we added the 9 fourths to both sides, and we also add the 25 fourths to both sides. So whatever we've created using the b over 2 squared formula, we add that to both sides of the equation. So this trinomial should be able to be rewritten as a binomial squared. So it's going to be x minus, and it's a matter of factoring. We're saying what times what makes 9 fourths, but the same two values have to add to make -3. If we can't factor and think of it, we go back up into the parentheses, and right before we squared it, that'll be the value that always goes there. So -3/2 goes right in there. We can use that same shortcut technique for this next one. So we're going to have a y plus, and we're going to say what times what makes 25 fourths, and the same two values have to add up to 5. Well, if we can't think of that, it's no big deal. We just go right up here into the parentheses right before we squared it, and that's what exactly goes there. Because if you think about it, 5 over 2 times 5 over 2 makes 25 fourths. If you add 5 over 2 to another 5 over 2, you get 10 over 2, which is 5. So it works out. Alright, and then next over here on the right side, I'm going to do it step by step. As you see here, my denominators are 4 for each of these. So I'm going to make the 1 4 over 4 to make it easier for us, plus the 9 fourths, plus the 25 fourths. So I'll write this left hand side over x minus 3/2 squared plus the y plus 5/2 squared. And now we'll just add, they have the same denominator, so we can add 25 and 9 and 4. So 25 and 9 is 34 plus 4 is 38. So we have x minus 3/2, that quantity squared, plus y plus 5/2, that quantity squared. So this looks to be standard form for the equation of a circle. We still need to go through the rest of the question, which said to give the center and the radius. The center and the radius. Well, the center is the h and the k value from the form that we initially looked over in the beginning of this video for the equation of a circle, where the h and the k, we usually take the opposite values. This 3/2 will be our h, so we'll say the center is 3/2, and it's going to be positive 3/2. So I stress taking the opposite values. And then the k value, we're going to take the opposite value of this positive 5/2. It's a negative 5/2. So the center is at 3/2 and at negative 5/2. And then we want like to figure out the radius. Well, the radius is basically taking the square root of 38 fourths. If I split that up to the square root of 38 over the square root of 4, I can take the square root of 4, which is 2. But I can't take the square root of 38, so I leave it alone. So that'll be my radius, the square root of 38 over 2. So I have my center and my radius, and then I box it in, and I am finished.